Hi guys, in this video we are going to see about OSPF. OSPF stands for Open Shortest Path First. Here Open refers it is openly available protocol. It is not owned by Cisco and it supports multiple vendor. It is link state protocol. Here link refers the interface between the routers, that is which is used to connect routers. OSPF maintains the state of all the link between the routers. Then OS, the name itself, we understood that the packet is routed on the shortest path. It uses register algorithm for finding the shortest path. Here the best path is calculated by using the cost metric. Cost refers here by the using formula 10 to the power 8 by bandwidth. Then OSPF support main range of OSPF is it supports unlimited opcode, so we can connect any number of device routers to it. It is the main advantage of the OSPF. OSPF only supports trigger update, and there is no periodic update. Addition to trigger update, it also supports refresh update. For some case, if a router cannot send any update for long time, then the refresh update will be sent for every 30 minutes. Then OSPF supports VLSM, that is variable length subnet mask, and CADR. Then OSPF is classless protocol, so the subnetting information are passed along with the packets. It uses multiclass address 224.0.0.5 and 224.0.0.6 for communication. Then it supports equal call load balancing. Then we continue to another slide. First, let me see about OSPF timers. Here it has two time intervals, allow interval and net interval. Here in this scenario, router 1 sends the allow packet and the router 2 sends allow packet as the response. Consider the scenario when router 2 sends packet and the router 1 cannot reply to the router. Consider this, if router 2 sends packet, at the time router 1 cannot able to send response, then router 2 continuously sends 4 packets at 10 seconds interval. After this 4 allow packet, router 1 still cannot able to send response, then router 2 consider the router 1 is dead. Then we going to see about states. There are 7 states in OSPF: down state, init state, and two-way state. These 3 states are used in establishing their neighborship between the routers. Then start state, exchange state, loading state. These 3 states are used to synchronize their OSPF database. Let's talk about the states in detail in below slides. First state is down state. Here both devices are just connected. And there is and the router A cannot know any information about router B, and router B doesn't know any information about router A. In any state, router 1 sends allow packet to the multicast IP address along with their neighbors and their router ID. Here router ID is nothing but to understand router ID, first consider the scenario. The router is connected with 4 interfaces. In other protocols like IGRP, EIGRP, where when the packet is coming from this side to S0 interface, the router is addressed using this IP address, whereas packet is coming in this side, this router is addressed by using this IP address and so on. But in OSPF, this router is addressed using a common name called router ID. Router ID is chosen either manually or the router can automatically assign one router ID to it. The router ID which we assign takes the first priority. If we didn't assign any router ID, then router takes the next longest IP in the loopback address. This IP, if this there is no any loopback address found, then it takes the largest IP address in the connected interface. In this case, if this L0 loopback address isn't found, 202.15.32.2 is taken as the router ID. But in our case, that is loopback address, so it is taken as router ID. then we just go to see next state. After the down and in state finishes, then there is if the router B sends a allow packet to the router 1 which is identified by the router B from the previous packet. That is, in previous packet router A sends its IP address. Router B now sends its router ID to router A itself, A only, that is, it unicast to A only, whereas in first case it multicast. After this two combination finishes, it is two-way state. Then we go to see about fourth state. In the two-way state, both the routers are trying to make a neighborship relationship between them. Next state is X start state. In this state, the DR, that is designated router, or BDR, backup designated router, is chosen. Here the master or slave is chosen by using election. After the both routers find each other, the both routers try to exchange the database. Which router wants to exchange the database first is chosen by the router ID. Here this router tells that I want to start exchange because I have this router ID, but this router tells that I have the higher router ID, so I will start it. Like that, it's telling this is exchange state. Sorry, this is X state. In exchange state, according to the decision which is taken, who has to exchange first, that router started to exchange their LSDB link state database to that another router. Similarly, then the second router starts to send the LSDB to the first router. This is exchange. Then we go to next state. In previous state, after the exchanges of the link state database, the acknowledgement is sent between both the routers. Then in loading state, what the router does is compare its database from the database which is sent from the other router. If it matches, it just finishes the communication. But if doesn't matches, this router sends the LS request, that is link state request, to the another router. Then as to the response, this router sends the LS update, that is link state update, to the other router. Then both router sends their request, they send their acknowledgement. You can see that the LSR link state request is going to this router, the link state update is going to this router. After that, the link state acknowledgement is sent, and it is in full state. Before going to this diagram, first there are two versions of OSPF version 2 and OSPF version 3. Version 2 supports IPv4 address only, whereas version 3 supports IPv6 only. Then let's continue. One important thing in OSPF is all that database is synchronized. You can see that in above state, it just compares the database, and if it doesn't matches, it asks for link state request again. So all the database should be synchronized. This is the condition in OSPF. If there are 200 routers, the 200 routers are all having the same database. This is the main advantage of OSPF, but sometimes it acts as disadvantage also. Consider this diagram. Consider this as integer routers. Okay. For example, if one new router is added in this space, just visualize. Then this router has to follow the 7 step, asking for the LS request, that is link the database, and it has to send the database. Like that, after it's getting any update, it has to send its new database table to this router, and in turn to this router, which this router has to send to this router, and going on like this. That is, if new network is added, it has to be updated to all the routers. It gives many big problem when in case of user network. For consider network which has it has 200 routers. If new one is added, all the 200 routers has to have a synchronized database. So all has to run the Digista algorithm to find the shortest path, and all has to have the database, which is difficult for storing such big database in low end routers. In the root node, the higher end routers can be used, which can store easily, but in lower nodes it is not possible to use the higher end routers. The lower end routers are difficult to store that huge information of databases because of its low memory. These are some of the problems which arise in OSPF, which can be fixed by using the concept area. Not only storage is problem, but also each node has to run their digital algorithm to find their path, that is best path. Before going to the area, let's discuss about the tables present in OSPF. OSPF has 3 tables, that is neighbor table, database table, routing table. Neighbor table contains all the information about its neighbor. For example, if router 1 and router 2 is connected directly, then router 1 has router 2 as his neighbor, and router 2 as router 1 as his neighbor. Then we have database table. Database table is nothing but it contains all the routes or information about all the routes to the network. That is, database table contains all the possible routes to the network. Then it has routing table. It contains only the best path to each destination. From the database table, the best path is calculated by using the formula 10 power 8 by bandwidth. Then the result, as per the result, the best route is calculated and placed in routing table. You can see all this table by using this command. Then go to area concept. I already told that to avoid some of the disadvantages present in this, the areas are introduced. Area is nothing but it is each area consists of some routers, and they are clubbed to a single area. Cisco recommends that is 40 to 50 routers should be present in each area to avoid the limitation in space and memory. In this scenario, you can easily see that some of the routers are clubbed to. You can see that some of the routers are clubbed into different areas. Here, area 0, the area ID is chosen from 0 to any number you can choose. Area 0 is acting as a backbone, and in area 0 there are most expensive network devices are used, because when area 1 wants to communicate this router, in area 1 wants to communicate to this router, it doesn't go to this like that. It has to send packets to this router, and from this to this, then it reaches the area 1. Then some of the terminologies you have to be known while configuring OSPF. First one is ASBR. It stands for Autonomous System Boundary Router. It is nothing but when we have to connect the router in OSPF to other routers present in other network where they configure any other protocols like RIP, EIGRP, IGRP, etc. That is, for example, when you have to connect to the another router where they configured other routing protocols, you have to make connection to this ASBR router only. Then another terminology is ABR. ABR stands for Area Boundary Router. That is, this router has to be is shared between this area 11 and this area 0. Then A stands for Autonomous System. I already told that area 0 is the backbone. When the router in this network has to send data to this network, it has to send through this area 0 only. This separation of area avoids the various limitation which we said above. due to this separation of this area, the router in this area doesn't have to participate in running register algorithm when changes are made in this area. For example, when initial is adding this area, the register algorithm is run only inside this area, and the routing table, sorry, the database table is updated only to this area only. Not all the other routers cannot participate in that process. This is the main advantages, and which limits the memory and storage problems. After the database table updated within this network, this area, only the best path is sent to the area 0, and it is only updated to all routers. Let's do the OSPF in Cisco Packet Tracker. Let's start our demo. This is how our network looks. Let's connect just as an IP. we send IP to it. After IP configuration, configure OSPF protocol. Go to CLI. OSPF is configured by two commands. First one is router OSPF, then administrative AES value, then network directly connected network address and the wallet mask. Here for router 0, it is 0. Then wildcard mask is nothing but it is complement to the subnet mask, network bit and its host bit, like that. Then area ID, we already talk about area in our explanation session. I just give any ID, I just give 0. Similarly, here 20 and 30 50 are also directly connected network, so 20.0.0. This is for first router. Similarly do it for all routers. After OSPF configuration finishes, just try to send packet from this PC to this PC. You can see that the packet is routed from this to this, not from this to this and this, because OSPF always chooses the shortest path. We can see that it is a registration and it is successful. That's all. Thanks for watching.